All right, hi everyone. We are looking at our next letter in our transformations over the quadratic and the square root equations. And we're going to be looking at the A value. Last week we looked at the H and the K and discovered how the H shifts it either left or right. And remember, insiders will lie. So a minus does not mean go to the left, and a plus does not mean go to the right. And we also talked about the K. K is outside of the parentheses, so outsiders tell the truth. Outsiders are honest. So a plus K did mean we went up. Minus K did in fact mean we went down. So the only letter that we have left to look at for our quadratics is the A value, and see how does the A, whatever number is in front of those parentheses, in front of that group, what does that do to our graph? All right, so let's talk about our first thing here. That is the absolute value of A is greater than 1. So that's what that stands for. Those bars are absolute value. Really, absolute value just means you want the positive of whatever the A number is. So if that was a -2 sitting there, I just want to focus on the +2. Okay, so take the positive of whatever your A is. So right now we are going to look at your A, whoops, sorry, still in highlighter, when A is bigger than 2. I'm sorry, bigger than 1. So our A value is going to be bigger than 1, and let's see what happens. All right, so looking at our first picture we have there, sorry, didn't quite make that big enough. Looking at our very first picture we have, this first U-shaped graph, this parabola, is the y equals x squared graph. This is our y equals x squared. So for that graph, and I'm going to move this down to the end, to the bottom here. Go make that a little bigger. So y equals x squared. There is in fact a number sitting in front of that x squared, and that is the understood 1. It is that understood invisible 1. So right now my A is a 1. So when we use that parent function and plot this graph out, like we talked about last week in our last video, I have a certain set number of points there that I will be using to draw the outline of our new parabola. Now, those 5 dots that I graphed, you do not have to use the same 5 every time. But again, you do want enough to get the U-shaped graph. So you need either the bottom or the top, and then some points on either side of that. So let's see what happens to this equation when our A becomes bigger than 1. So let's look at our 2 pictures here and see what actually happened. From the graph on the left to the graph on the right, it has become narrower. So now it's more narrow, which is another way to say it got skinnier. We do still have those same points, but now they're not as far out as they were before. So this time on that graph, I can really only get 3 dots, while on the first one, I got 5. That's because it's gotten so skinny. Those last 2 upper dots are now way outside of the grid. So our graph got narrower. So when that happens, when our graphs become narrow and they become skinny like that, we call it a vertical stretch. Sorry, that's a little too big there. Let's shrink that down. We call that a vertical stretch. So think about what might happen if you had a balloon, and you took that balloon and you pulled it from the bottom and you pulled it from the top. Well, if you're pulling from the top and bottom on a balloon, then the sides of the balloon are going to get in and get closer together. So again, that balloon becomes taller and it becomes skinnier. So that's the same thing that is pretty much happening to these graphs. Oops. All right, so let's see how we can use that idea of getting skinny and narrow when it comes to actual equations. All right, so we have our parent graph up here, the f of x equals x squared, or y equals x squared. We're going to use some settled points here to draw these graphs out. So we're going to have our starting graph here. So we have the point -2, 4. We have a -1, 1, 0, 0, 1, 1, and 2, 4. So those are our starting points. Connect these dots, make our U shape. So there we go. Now, that A value is going to do something to only one set of points. Since we are looking at vertically changing this, the only numbers that are going to be multiplied are the y's. So whatever our A number is, that's what we're going to multiply those y numbers by. So let's see what happens in our next equation, and let's get our A value. All right, so before I get my A, I'm going to set up my table, our initial beginning table. So -2, -1, 0, 1, 2 for the x's. And then we have 4, 1, 0, 1, and 4. All right, and again, we're going to do something to these y's. We're going to multiply by something. And let's go to that equation and figure out what that something is. All right, so looking at our equation, which I'm going to highlight here, looking at our equation, our A is the number in front of x squared. In front of that x squared. Meaning my A is just that +2 that's there. Just the 2. So when I get ready to multiply those numbers, I'm going to multiply by 2. So let's make our new table. Okay, so there's our x and our y. The x's stay the same. The only thing that changes are the y's. So we're going to take each of those numbers, multiply by 2. Let's see what we get. All right, so if I have 4, do a yellow here, it's a little easier to see. So if I do 4 times 2, that gives me an 8. Okay, let's try the next one. Then I have the 1 times 2, which gives me a 2. Then we'll try the next. 0 times 2 is a 0. Keep going. 1 times 2 is another 2. And then our last one, 4 times 2 for another 8. And then I've got enough points there that I can draw my new graph. So let's take those dots, plot them on the grid, and let's see what happens. All right. Now, -2, 8 is way up high. I don't have room on this graph, but I can do the next one, -1, 2. And I can do the next one down, 0, 0. And then 1, 2. And same problem with 2, 8. It's just too high for this grid. So here is our new one. Now, let's compare this real quick, just for a second, to the original. We had -2, 4, which was outside of the graph, then 1, 1, 0, 0, sorry, -1, 1, 0, 0, +1, 1, and then +2, 4. So we can see now that the two sides of that parabola are getting closer together. So it did, in fact, get narrower. So let's use that idea of multiplying and look at our next parent function, which is the square root. So the same square root equation we worked with last week is here. And again, we're only focusing on the A. And since my part needs the absolute value of A, I only need the positive A, not the negative one. We'll get to negative in a little while in our next video. That's where we get the whole sideways parabola shape. Is the top side of that is the positive version. The bottom side of that is negative. So let's see what happens. Again, we are bigger than 1. So let's get our original graph up here. This time we have y equals the square root of x. And we've got some similar key points here that we'll use with our graphing. So this time, again, for the square root, when we are bigger than a, our graph shifts, not shifts up, I'm sorry, our graph seems to get taller. Okay, our graph seems to get taller. So it is still, in fact, being stretched, but not necessarily getting skinnier. It's a little bit different when you're dealing with a sideways U shape. Okay, but our points are still getting stretched. So we still have a 0, 0, but we don't have the 1, 1 anymore. Now it's way up high. And then same thing, the others just keep going up. So there is still a vertical stretch happening. Okay, there is still a vertical stretch, but this time again with the square root, it looks more like the graph is getting taller than it is getting narrow. So it looks like it's getting a little bit taller there. All right, so let's use that same idea of multiply when we look at our square root. All right, let's start with our original points, the x and the y. All right, this time, since we're only dealing with the positive side of a square root, sorry, trying to erase, we have 0, 0 for our first point. Then I have 1, 1, and then 4, 2. So there's some points that we can work with. All right, and there's our original. So again, we're going to multiply, take our original numbers here, and we're going to multiply them. Sorry, did not mean to erase my drawing. So we're going to multiply. All right, like before, we need to see what is the A value so that we can compare how these two graphs change. So just like the one before, I want the number in front of the square root, not inside it. If there's a number inside, that's your H value. We want the one outside. So right now, my A is a 2. So let's take your original numbers. We had 0, 1, and 4, 0, 1, and 2. We're going to take those y numbers and multiply by a. Multiply by whatever the a is. In this case, my a was a 2. So let's get your new numbers and redraw it. All right, so x and y, the x's stay the same. All right, now we're going to multiply. So 0 multiplied by 2, still 0. So 0, 0 still happening. All right, now 1 times 2 is a 2. So now we're at 1, 2. And then our last one over there, 4, 2, 2 multiplied by 2 gives us a 4. So 4, 4. And there's our new graph. Like the other one, I'm going to go ahead and stick the original one up here just so we can see how it changed. And again, it does look like it got taller. Okay, but in fact, again, there was that vertical stretch. We pulled it up. Okay, for that vertical stretch, we pulled it up and down. All right. Now let's see what happens if our number, whatever that A is, this time it's going to be between 0 and 1. So this time we are between 0 and 1, because that does have an effect on what our graph is going to do. All right, we've got our original one up here, y equals x squared. And right now my A is that understood imaginary 1 in front of it. And let's get our original dots, because again, everything's going back to what these dots are doing. All right, so there's our outline. This time, check out the shape of this graph. It's not quite so much V-shaped anymore. This time it's opened up a whole lot. Just like a flower opens up, it's gotten wider. This time it's gotten wider. So when your graphs open up like that and they become much wider than the original, because we're still going to be looking at some points here, but again, they're much farther apart this time than they were close together. And they're much farther apart. Okay, this is wider, or what we call a vertical compression. So go back to that balloon idea for a second. You have a balloon, and this time, instead of pulling it at the top and the bottom, this time you're squishing it from the top and bottom. So as you squish that balloon down, the sides are getting pushed outwards, left to right, which is what's called the compression. You're pressing down on the top and bottom while the sides are going out. That balloon's getting wider as you squish. So the multiplying idea is still going to be the same here. It's just a different kind of number. So again, we've got our parent function here. Let's get the same set of xy points for the quadratic. We've got -2, 4, 1, 1, 0, 0, sorry, -1, 1, +1, 1, and then +2, 4. And again, we are going to plot these points to check the shape. So there's our 5 dots. And we need to figure out what are we going to multiply these numbers by. Okay, what are we going to multiply by? Multiply. And again, it depends on what the A is. So let's take a look at our example that we have here. Again, the A is in front of the x squared. So in this case, my A is a 1/2. You can also use 0.5 if it's easier for you to multiply with a decimal versus a fraction. And we're going to take those same set of numbers and multiply them. All right, so let's get our originals. X and Y. All right, so -2, -1, 0, 1, and 2. We originally had a 4, a 1, 0, 1, and 4. And now we multiply. And again, since our A is a half or 0.5, that's what we're going to multiply by. So let's make our new table and see what we get. Sorry, bear with me for a second. I'm just going to move this down so I can make my table. All right, so X and Y. X's stay the same. -2, -1, 0, 1, and 2. And now let's multiply. So 4 times 0.5 is a 2. So -2, 2. Okay, there's our first dot. Now we have 1 times 0.5, which is 0.5. So we're just halfway up when we come to the 1. And then 0 times 0.5, still 0. +1 again, times 0.5, 0.5. And then our last one is still a 4 times a half, which is a 2. So let's get our last remaining dots up here. Our half, and then our last one at +2, 2. And there you can see we are pretty wide here. If I throw the old dots back up, you can see that we did open up more than our original graph. It is wider here. Okay, so the same is still holding true. Let's make sure it holds true on our last example for the square root. Again, we're still between 0 and 1. Oh, that didn't come out very good. Let's fix that. And 0 and a 1. We have those same key points as before. And again, this time it was a compression. So this time it looks like it kind of shrunk down a little bit. Okay, this is still, though, if we look at those original points, it's still a vertical compression. It just has the appearance of being squished and flattened out more. So let's get our points and practice our multiplying for our last example. All right, we have our original. We have 0, 1, and 4 for the x, 0, 1, and 2 for the y. Okay, so there's our original. We're going to use those same points and we're going to multiply. We just need to figure out what is the a value that I'm going to take those three numbers and multiply by. So we have a 1/2 sitting in front of that x squared, which means my a is 1/2. So we're going to make our table and we're going to multiply these numbers. All right, so for our x and our y, we have 0, 1, 4 and 0, 1, 2. We're going to take those numbers, multiply by, again, a 1/2. Oh, sorry about that, guys. It crashed on me for just a second. Give it a second just to reload. Here it comes. We were almost done. All right, here we go. Multiply by 0.5. So let's take those three numbers and do just that. X and Y, 0, 1, 4. And now 0 times 1/2, still a 0. So we're still sitting at 0, 0. Now 1 times 1/2, 0.5. And then our last one, 2 times 1/2 is a 1. So sure enough, we do look flatter. We are closer to the x-axis than we were with our original. And again, I'm going to throw the original up here so that we can see how it looks. So again, it did squish it down. It did look flatter. All right. So guys, I hope you enjoyed learning a little bit about the a value. If it's bigger than 1, how that makes our graph more narrow, makes it a little more skinnier, or in the case of the square root, it tends to pull it up or down a little bit. And then I hope you also enjoyed what if the a is between 0 and 1, how for the quadratic, it opens it up, where it does kind of start to get a little bit flatter. And same thing with the square root. It does tend to squish it down so that it appears to get flatter as well. So guys, make sure you check out the second video that's going to be coming up soon in your lesson. And in the second part, we will talk about the sign of A. Is it positive or is it negative, and how that changes the shape of the graph. All right, hope you enjoyed, and you guys have a great day.